Okay, this recording is to help you with lesson 10.06, which is your graphs of polar equations. Alright, we are going to be using our graphing calculator a lot in this lesson, so I'm going to quickly show you how to change it to polar mode. Alright, so I talked a little bit about this in lesson 5 on the mini recording, but let me application share and show you exactly how to change it so it's in polar mode. Alright, so obviously when we want to go to mode, and down here where function is highlighted, and yours might be highlighted in parametric still, we want to scroll over and make sure polar is the one that's flashing and hit enter so that the black box is moved over to the pole. Make sure you are still in radian mode. So I'm just going to hit second click. So now we are in polar mode on our calculator. Okay, first things first, it says identify the type of polar graph. There are several different types of graphs we have for polar functions. It can be a cardioid, it can be a limacon with inner loop, a dimpled limacon, a convex limacon, a rose curve, and that's what we actually have here, rose curve. It looks like a flower, hence the rose, and the number of petals actually depends on what you have in front of theta, okay? So, and that is called your A right here, because if we look here, or, yeah. So, A is the length of each petal, and the number of petals is based on the value of n. So because n here is 2, we have 2 times 2, which is 4. That's why we have the 4 petals, right? Notice that it says if n is even, there are 2 n petals, and if n is odd, there are only n petals. But this one is your rose curve. You can also have a circle and a lemniscate. I'm not the best at these pronunciations, but you can find all of the different types of graphs actually listed in the online lesson of 10.06. Okay, they do have you test for symmetry with respect to the line pi over 2, the polar axis, and the pole. Now the line of pi over 2 is simply checking to see if it's symmetrical about the y-axis. The polar axis is checking to see if it's symmetrical about the x-axis. And the pole is seeing if it's symmetrical about the origin. So instead of following these rules of plugging negative in for both r and theta, or plugging it just in for theta or just in for r, I like to graph it and kind of look at my graph and see. So that's what we're going to do for this one. Okay, so the first thing we're going to do is I'm going to go turn my calculator back on, and let's plug in 3 cosine of 2 theta. And notice theta is your x button there. And when I graph it, oopsie, that's the wrong one. I'm already on 10. I'm on my second one. Plus 6 cosine theta. Here we go. This is the one that I wanted to graph. There we go. Alright, I need to kind of extend my window a little bit because it looks like my graph is cut off there. It's actually not quite the case, so I'm going to zoom out. And I kind of see what my whole graph looks like. Now, yes, it kind of gets indented here and cut off, but we get a general idea. So looking at this, we can see that obviously it's not symmetrical to the y-axis, right? Because if I were to fold it over the y-axis, it wouldn't lay on top of each other. It is symmetrical over the x-axis. It is not symmetrical over the origin, meaning if positive x, positive y is on there, so is negative x, negative y. That's not happening here. Okay. So it's only symmetrical to the x-axis. So we know the x-axis is the polar axis, so we would say that it's symmetric with respect to the polar axis here. Okay, let's look at the next one. The next one from here on out are just graphing. So let's sketch a graph of the polar equation, r equals pi over 6. And if this is on the homework, unfortunately, yes, you do have to sketch your graphs out because that's the whole purpose of the lesson. Alright, so you will need to scan in your graph. So r equals pi over 6. I'm going to change my window back to the standard viewing window. Oh, and this one's really tiny, so I'm actually going to zoom in more. There we go. It looks like it's a circle. Oopsie. So that's what we actually have for r equaling pi over 6. It's a circle. And notice it does match up to my graph here. My window's a little bit different than what I have here, but we both end up with circles. Okay, the next one, we're going to graph 3 times 1 minus cosine theta. Remember that the 3 is on the outside of parentheses. So 3 parentheses 1 minus cosine theta. Let's graph, and I will probably have to change the window here because it looks kind of like just some hills on the side. I'm always going to start in standard and see. That's pretty good because I know what it looks like up close. So it kind of looks like a heart on its side. Let's see if that matches up. And it is. This is what we call a cardioid. So heart, yeah, because cardioid, you think of heart. Good. So that does match up there. And then the last one, 3 sine of 2 theta. Just looking at this, I should know this is a rose curve. So let's check it out. And it's a rose curve with 4 petals nonetheless. So let's just check it out. So clear this out, and we have 3 sine of 2 theta. Graph that. Oh, and there's our rose. Let's zoom in just a little bit. Ooh, there we go. That's kind of pretty. There's our rose with 4 petals. And it matches up perfectly to the graph that they have down here.